Okay, so now let's look at question 7. So go to your notes for question 7. As I go through, you take down the things I've written and try to digest it so that in class we can just do a summary and then we go on to question 8. Okay, so for question 7, right, before we go to that, um, remember we actually have been doing the case for proper fractions. So what happens when it's improper? Okay, so I remind you, improper algebraic fractions, the degree of the numerator is larger than or equals to the degree of the denominator. Okay, so what happens when when it's an improper algebraic fraction? We actually need to do long division first and then express it in a sum of a proper fraction and polynomial by the division algorithm. Okay, so you actually see things that we have learned before. So actually these two are for your 4.1. Okay, and once you have a proper fraction here, then you can use what you have learned previously in this section to change them into partial fractions. Okay, so let's look at this question. So we see that, okay, this one, the degree is degree 3 because of the cube. Okay, so we know for this one, if this is degree 1, this is degree 1, overall is degree 2. Okay, so we know that the degree of the numerator is larger than the degree of the denominator. So this is an improper fraction and we have to do our long division. Okay, so of course before we do our long division, we will want to expand out the denominator first. Okay, so we expand our denominator, we get x squared plus 2x minus 3. Okay, so now we do our long division. 4x cubed plus 7x squared minus 13x minus 2. Okay, so we just do our long division. So this is normally we work with linear factors, right? But once in a while you have to know how to divide by a quadratic factor. So this is what we're going to do in this case. So the first thing we look at, what do we need? So we actually need 4x. So we put it here, aligned to the x. So we minus 4x cubed plus 8x squared minus 12x. Okay, and so this gives us 7x squared minus 8x squared is negative x squared. Negative 13x plus 12x is minus x. And then we shift down the negative 2. Okay, so now we just need a negative 1 here. And then we have minus negative x squared minus 2x plus 3. Okay, so you got negative x plus 2x is x, and then negative 2 minus 3 is negative 5. Okay, so this is what we get. And just to remind you, this is called your quotient, this is called your dividend, this is called your remainder, and this is called your divisor. Okay, so now remember, once you have done a long division, the next thing is to express it in a proper fraction and a polynomial using a division algorithm. So what I mean by that is, let's recap our division algorithm. So it's dividend equals to divisor times quotient plus remainder. Okay, so let's just put them in there. So we have your 4x cubed plus 7x squared minus 13x minus 2 equals to x squared plus 2x minus 3, and multiply by your quotient, which is 4x minus 1, and then plus the remainder, which is x minus 5. Okay, so of course at this point we know that your x squared plus 2x minus 3 is actually x plus 3x minus 3, x plus 3x minus 1. So we can of course write it this way: x plus 3, x minus 1, 4x minus 1 plus x minus 5. Okay, I have a reason for writing this. Later you'll see why. Okay, give me a while, let me erase this. Oh no. Hold on. Okay. Hold on. Okay. Okay, so yeah, you have this, and then like I mentioned, I have a reason for doing this. So what we want to do now is to divide throughout by x plus 3, x minus 1. Okay, the reason why we want to do that is because we want to get back what we had in the question initially, which is this. Okay, so when we divide throughout, right, the left hand side will become the question. So we'll get this. Okay, and you see that it becomes a question. And then on the right side, you see that when I divide, right, I'm left with 4x minus 1 here, and then it will be x minus 5 over x plus 3, x minus 1. Okay, so this is what I mean by this is the polynomial, and this is the proper fraction. Okay, and so now what we need to do is just to work with the proper fraction and make them into partial fractions. Okay, so this is something that we have done before already. So once again, we let your x minus 5 over x plus 3, x minus 1 equals to a over x plus 3 plus b over x minus 1. Okay, why we use this is your case 1. Okay, because they are both different linear factors. Okay, so remember we multiply throughout by the denominator. Okay, then we have x minus 5 equals to a x minus 1 plus b x plus 3. Okay, so once you have this already, then same thing, remember we look at how we can get rid of one of the variables. So you can get rid of a by subbing x to be equals to 1. Okay, because when we sub it in, the entire thing becomes 0. Okay, so 1 minus 5 equals to a 1 minus 1 plus b 1 plus 3. Okay, so we will have 1 minus 5 is negative 4 equals to 4b. Okay, so we know b is going to be equals to negative 1. Okay, so now the other one, we sub x equals to negative 3. So same thing, negative 3 minus 5, a negative 3 minus 1 plus b, negative 3 plus 3. Okay, so you're going to get negative 8 equals to negative 4a. And so a is going to be 2. Okay, so now they have everything already, right? It's just a matter of putting everything together. Okay, so we know your x minus 5 over x plus 3, x minus 1 is going to be equals to your 2 over x plus 3 minus 1 over x minus 1. Okay, and so finally, to answer the question, remember you need to answer the question eventually. So the final answer is going to be, sorry, this is a cube. Okay, we write out the question. And so this will be equals to the polynomial, and then you write the partial fractions. Okay, And so this will be the final answer. Okay, so we look at this entire question, right? The only new things are this part. Okay, not really only, but there are quite a number of new things. So these are the new things. The remaining parts are actually things that you have gone through before already. So this you should know already. Okay, so it is actually using what we have learned to answer this question, but we have certain additional steps that we need to do. Okay, so this is for improper fractions, the case where the degree of the numerator is larger than or equals to the degree of the denominator.